with 6.4, let me see. This is inverse.
Right.
It's referring to inverse. It's very similar to okay, not very similar. I'm saying the symbol sometimes might be mistaken for first derivative, but yeah, it's not really something in our faces to say they look very alike. They're quite distinct. It's a 2-mark question, and with all 2-mark questions, the big idea is just understanding uh, what they're asking for. Because normally, if you understand what someone is asking for, it's easier to give them what they want. It's like a baby that won't stop crying. The moment you know what that baby wants, the baby gets. So
Right.
yeah. So I don't know why I used that analogy, but just did.
It makes sense. It makes sense.
Mm-hmm. Another reason why people should stay away from babies, because unfortunately we will not know what those people want. So
Yeah.
might as well, might as well just stick to yourself. Anyways,
They're
so
too permanent.
yes, the two feminines.
Babies are too permanent.
Very, you're going to die before them. So yeah, let's be careful. Let's be careful. So anyways, so it says here for which values of x. You see, they're asking for the x values as well. You see, the question has to be very yeah, the question will always be very direct. They're saying for which values of x will the x value multiplied by the y values of the inverse, like where will this expression be a negative number? That's what this is asking. It's asking where will the left side be a negative number? That's the question. Literally, where will the left side be a negative number? You see, if you want to look at it in another light, it's basically asking for which values of x will the left side be a negative number. That's like a spin-off of what we have said. But let me just write it like that, the way I've just said it now. So this could be asking for which values of x will the left side be a negative number? Now, if you look at the left side, there are two things that affect the left side. See, the first thing that affects the left side is x values. The next thing that affects the left side is y values of the inverse. So this question is asking where will the left side be a negative? So to make our life easy, we just have to remember that for the left side to be a negative, you need to have this as plus while this is negative. Or you need to have this as minus while this one is plus. That's the only way the left side is going to be a negative. If one is a plus while the other is a minus, if one is a minus while the other is a plus. Does that make sense?
Yeah.
Perfect. So as long as you can remember that, the next thing now is being able to judge what these expressions are talking about. You see, if you look at it nicely, I mean, like x is just referring to x values, and then this is referring to y values of the inverse. See here, this is x values along the x axis. This this next symbol here, let me use a different color. This next symbol is referring to y values of the inverse of f. That's why here you have a negative and there is an exponent to show that you're dealing with inverse. So for a question like this one, we do have to be a bit creative. In terms of us being creative, yeah, you have to be strategic. Now, in terms of us being strategic, yeah, I'm going to mention something. I'm going to mention something that I may have to mention a couple of times, but it's okay. We'll just mention it over and over again until until something sticks. So the big idea is, with inverse, what we all know about inverse is that, let's put your inverse. The whole essence of inverse is that x values become y values, and then y values become x values. That's what inverse is, right?
Mhm.
Yeah, but the
Right.
issue is, apart from just the x values and the y values swapping, what swaps is also all the properties. See? So um, properties of x become, and I'll explain this just now. Properties of x become properties of y, vice versa. For example, the domain, the domain
Will
becomes,
become the range.
yep, the range, the range becomes the domain.
Domain.
Yeah, there we go. So yeah, that's basically, the the big idea here. Now with our sketch, right? The one thing we can remember is, yeah, let me take things slow. So if you're looking at our expression, right, do you see that this expression is talking about x values along the x-axis?
Hmm.
The
I,
this
I
this
didn't at first, but yes.
Yeah, talking about x values along the x-axis. X values from
Hmm.
negative infinity until positive infinity. That's
Right.
what the first portion of the expression is talking about. The second portion is talking about y values of the inverse. So do you see that's kind of interesting? Because y values of the inverse are technically
The x
x
values of f of
of
x.
the original one. Yeah,
Hmm.
you get it. You see, y values
Right.
of the inverse are x values of the original graph. We can even write it out so that it sticks in our head. You see,
So it's
y
basically the
values.
same thing, as in probably like x squared, whatever it is that you're gonna get.
Let's psychoanalyze the question a bit more. Y values
Right.
of the inverse are x values of the original graph. Yeah, so that's kind of creepy. That's kind of creepy. But let me make life a bit easier for us. So if we know our background knowledge well, right, we will always be able to draw two graphs um, on a Cartesian plane based on the line of inverse. So what I mean is, if you look at what our image looks like, let me maybe shrink it because I think I need to draw my own here so that it's not too, mechanical. So if you have we have a Cartesian plane here, and then we also have this graph here. This is
Hmm.
the original graph we're given. Hey, hey, come on, man. Now, if you know your theory well, which is not important, what we will know is that, okay, if this is an original graph, the line of inverse will be here.
Hmm.
Mhm. Now, the equation is just y is equal to x. Doesn't matter.
Hmm.
Now, what we know
Yeah.
is, as long as you have a line of inverse and you have an original graph, drawing the inverse is easy because you just have to look at how this is going to be what this is going to show you that this picture, you're just going to have a mirror image on this other side. You see? So to do that, you just compare things like how you have an arrow here, and then
It's
you have a
coming
line
towards
here.
the y-axis.
So if you have an arrow here on one side of the green line, the other arrow will be somewhere there if there is an inverse. Because you see, there have to be a reflection along the green line. Here,
Right.
these have the point here has to be reflected up there. You see. So
Hmm.
if this is a point here, your reflection will be like somewhere up there. So your image will technically look something like this. You see,
Right.
and you see, it's all about a reflection along the green line because they have to be reflected. If there's a point here, you can almost see the distance there Whatever this distance is, it has to be the same distance going the other way. And then whatever this distance is, it has to be the same distance going the other way. You see, that's how you get these arrows. And then the moment you have those arrows, you can just draw a curve like that. You see, this is already showing you that, okay, this one is avoiding the x-axis the same way this one is avoiding the y-axis. So you have two inverse graphs. You have two graphs, right? You have the one here for f of x, and then you have the inverse. Fine. So before we carry on psychoanalyzing our question, let's just do what's easy first. Or technically, this would only be easy or would be doable if we know how to do the sketch. If you know how to draw the sketch, we could do it, right? We just showed it's not so bad. So now
Yeah.
what we want to do is we want to, let's look at our question. It's saying where the x values multiplied by the y values of the inverse, where is this expression smaller than 0? And we said we need to look for cases where this is a positive x value while we have negative y values there. Or we have to look for negative x values while we have positive um, y values of our inverse. So saying it in words, it's a bit like gibberish sometimes. And then when you're looking at it logically, that's all we have to do.
Yeah.
Yeah. So now all you do is you look at your image. You can see here, you see one side here has positive x value. And then one side here has negative x value. You see it's like plain as day. Negative x values, positive x values. You see it, right?
Right.
Yeah. So now let's just work with our x-axis and let's work with our pink graph over there. So all we're looking for is, to start off, right, we are looking for a case where we have positive x values. So let's look on the right side. We're looking for cases where we have a positive x value while having a negative y value for our image. Do you see that that's not happening at all? Because everywhere here where we have these positive x values, we don't have any case where our y values are a negative. You see it?
Wait, can I just pause you?
Yeah, definitely. Hello, hello.
The x values, I'm looking at this. See, you're right when you said that when you're saying it out loud, it sounds like gibberish, but when you're psychoanalyzing it makes sense. The x values of the f of x being multiplied by the x values of the thingy, the inverse. You keep saying
No,
why? Why is that?
no, hold on. Remember, our concern here has nothing to do with this white line. This white line is obsolete right now. We might as well even write it out for now. There, it's gone. Because you see, our question is not even talking about it. Our question is talking about the inverse. So if you're looking at our inverse now, what we are doing is, you see here, we have to check where do we have positive x values. We have positive x values here, right? And then where do we have negative y values of our inverse? Do you see we don't have any negative y values for our inverse?
Right.
Our inverse has no negative y values at all. It's all up there. You see? Yeah. So what that means is this scenario will never happen. So we don't have any solutions for that scenario. So you rule it out. You move on to the next option that could give a valid answer. So what we're now looking for here is cases where we have negative x values. You see that we have negative x values here. You see it, no? Yeah. And then you see that we should look for cases where we have negative x values while having positive y values of our inverse. You see that's happening all the way here because we do have those negative x values and we also have positive y values of our inverse here. Yeah. So in terms of our answer, we can see that all that is happening from 0 going all the way to infinity, negative infinity. From 0 going all the way to negative infinity, you do have negative x values and you do have positive y values for the inverse. Because you see all these y values here, all the way to negative infinity, they will all be above the x-axis. They'll all be positive. They'll never go down. So
Right.
yeah. So for where x is smaller or equal to 0, that is the point or those are the x values where your graph has negative x values while also having positive y values for the inverse. It will happen everywhere from 0 to negative infinity, of which I think we have to exclude this here. You see, because the question is excluding the 0. It's just saying below 0. So x has to be smaller than 0.
Mm-hmm.
Yeah, because if there's one line there, here there should also be one line. You see what we have done it there.
Okay. So there was no need for the f of x. I think that's what brought on the confusion.
Well, yeah, the f of x was there to help us what you call see what the actual inverse looks like. Because if we don't have f of x, I mean,
They don't know
seeing
what
what
the
the
inverse
inverse
is.
is, yeah, we won't know what the inverse is, or we would not have been able to draw it so that we can like use the image to like work out
Right.
what we are working out. Yeah.
Right.
But then, I mean, just for interest's sake, if we go back to what we said here, we said y values of the inverse are x values of the original graph. Yeah, it's kind of crazy.
Yeah.
Crazy. But
Okay.
it is what it is. It is what it is.
Okay,
Yeah.
so the next question is question 10.3.2.
Okay. We shall do it. Let me just stop this one.